All right, so we are going to work with section 2.1 on trig functions of acute angles. So what you need to know in this particular section is we're going to be working with right triangles. And with that being said, typically what you're going to see is that the right angle is always going to be letter C. From there, we're going to have angle A and angle B. And what I want you to see is angles are always capital letters. So we've got angle A, which is that angle up there. If we go across from angle A to the opposite side, we would label that as side A. Over here, we've got angle B. It's another acute angle. And if we go across from angle B, this is going to be side B. And if we are looking at angle C, which is our 90-degree angle, and we go across from angle C, we're going to label that as our side C. The next thing I want you to understand or look at how I wrote that out is that sides are always lowercase. Letters. So depending on what angle you're working with, your trig functions will change. Meaning, if I asked you to do the sine of angle A, well, from angle A is my blue letter, I would have to note that side A would be my opposite, side B would be my adjacent, and side C will always be your hypotenuse because it's across from the 90-degree angle. So from angle A, sine would be side A over side C. However, if I asked you to do the same question, except I said sine of angle B, we would have to pay attention to from angle B. From angle B, side B would be my opposite, side A would be my adjacent, and side C would be my hypotenuse. That will never change. Your opposites and your adjacents will change depending on which angle you're working from. So again, if I'm working with side B, my sine of angle B would actually be side B over side C. So you really do have to pay attention to which angle you're working from, and I very strongly suggest that you write opposites, adjacents, and hypotenuses depending on which angle you're working from. So we can do the same thing if I'm talking about cosine. Cosine of angle A is my adjacent over adjacent over hypotenuse. So this would be side B over C, where the cosine of angle B would be, again, adjacent over hypotenuse. So this would be side A over C. The tangent of angle A, opposite over adjacent. From angle A, the opposite side is side A, and the adjacent side is side B, where tangent from angle B, again, opposite over adjacent, would be side B over side A. So please just be very careful about which angle you're working from and pay attention to which is what's going to be the opposite and the adjacent. So we are finding the values in example 1 of the trig function for angles A and B. So we're going to go through it. We've got sine of A. We're going to find cosine of A. We've got tangent of A. We're going to do their reciprocals. Cosecant, secant, and cotangent. And all of this is going to be done from angle A. So from angle A, I'm going to label this as my opposite. I'm going to label this as my adjacent. And I know that 25 is my hypotenuse for a couple of reasons. 1, it's the biggest. And 2, it's across from the 90-degree angle. So sine is opposite over adjacent. Flip that fraction for its reciprocal. Cosine is adjacent over hypotenuse. Guys, I'm so sorry. Let's back that up. I don't know what I was looking at. Let's go back to sine. Sine is opposite over hypotenuse, so 7 over 25, and flip that fraction for cosecant. Cosine is adjacent over hypotenuse, so 24 over 25. Flip that fraction for its reciprocal secant. And tangent is opposite over adjacent, so 7 over 24, and flip that fraction for its reciprocal. Now let's move into angle B because it wants us to do them for both. So I'm going to set it up the same way. Write it all out. Sine of angle B, cosecant of angle B, cosine of angle B, its reciprocal, and tangent of angle B. So from angle B, I'm going to pay attention to here in blue. 24 would be labeled as my opposite, 7 would be my adjacent, and the hypotenuse doesn't change. So from angle B, sine would be 24 over 25. Flip that fraction for its reciprocal. Cosine would be 7 over 25. Flip that fraction. And tangent would be 24 over 7. Now, question B says, what do you notice about some of your answers? What I want you to kind of pay attention to, and these are called cofunctions, is that the sine of angle A is actually the same thing as the cosine of angle B because they flip-flop angles, so therefore the opposites and the adjacents flip-flop. If I am looking at the cosine of angle A, that's going to be the same thing as the sine of angle B. They're called cofunctions. And with cofunctions, what you're going to see is that the sine of angle A is going to equal the cosine of angle B. And what we need to know is that angle A plus angle B are complementary. And the same thing would actually work for their reciprocals, that the cosecant of angle A is equal to the secant of angle B. And tangent and cotangent, they're also called cofunctions. So the tangent of angle A is the same thing as the cotangent of angle B. And again, what you need to know, that will only work if the angles are complementary. So moving into special right triangles, these are our 30, 60, 90 triangles and our 45, 45, 90s that I kind of begged you guys a little bit ago to memorize. So if we're looking at our 30, 60, 90 triangle, here's our first one. So we have 30, we have 60, and we have our 90. Hopefully you're remembering that across from 30 is always 1. Across from 60 is always square root 3. And across from 90 is 2. Hopefully that's kind of ringing a bell, no matter what direction that they are written. And then we've got our 45, 45, 90. If my angles are the same, we know that this is an isosceles triangle, so please keep that in mind. That's why both of these sides are 1s. They're exactly the same thing. And you've got your hypotenuse of square root 2. Please get this memorized. This is absolutely critical that you have this memorized. So if we're looking at this first picture, I'm going to draw my triangle in the exact same way as we see it. Hopefully you see the 45 and we know that those sides are the same, so right away we should know that x is 13. You also have Pythagorean theorem in your toolbox, so at this point if you know this side is 13, you could set up 13 squared plus 13 squared equals y squared. The other option that we have done in the past is set up your ratio triangle and set up your ratio 13 over 1 equals y over square root 2. Do your cross multiplying and we get out that y is 13 square root 2. big thing I want you to know on this one, no decimals. Absolutely no decimals, so do not stick that in your calculator to give me these answers. You have to use your special right triangles. Similarly, I would set up my ratio triangle in the exact same orientation as the picture. I know that these are 45, 45, 90s, so I'd have 1, 1, square root 2. To find x, which is also finding y because they're the exact same thing, I would set up x over 1 equals 30 over square root 2. And what I would see is I'd right away have that answer, 30 over square root 2, but I'd have to rationalize because we can't leave radicals in the bottom. So I'd have 30 square root 2 over square root of 4. I want you to see that root 2 times root 2 is the square root of 4. Square root of 4 is normal 2. So at this point I reduce. Normals go with normals, roots go with roots. Both of my sides are 15 square root 2. I only have to do that work once because I see that this is a 45, 45, 90, so it's isosceles. Looking at this next problem, same thing. Draw your triangle in the same orientation, make your life a whole lot easier. Do your 1, 1 square root 2. So I would have x over 1 equals 10 square root 2 over square root 2. What's really nice about this one is, look, the square root 2's cancel right away. So then I really just get down that x is 10. But because of my knowledge of 45, 45, 90s, y is also going to be 10 because those sides are the same. Now we're switching it up a little bit here with D. We're doing a 30, 60, 90. So I have to set up a different triangle. Here's 60, here's 30, here's 90. I'm going to use my ratio triangle. Across from 30 is 1. Across from 60 is square root 3, and my hypotenuse is 2. Does not matter which side you solve for first. So I'm going to do 25 square root 3 over square root 3 equals y over 1. I chose that because the square roots cancel out. And what I see right away is that y is equal to 25. Dividing by 1 isn't going to change my answer. So then to set up x, I'm going to have 25 square root 3 over square root 3 equals x over 2. I am going to cross out the square root 3's right away. And then this is really going to become a 1 down on that bottom because everything canceled. So the 1's just a placeholder. So I cross multiply. X times 1 is equal to 2 times 25. So x is 50. Next problem, set up my ratio triangle. I have my 60 down there, which makes that my 30. Across from 30 is 1. Across from 60 is square root 3. Hypotenuse is 2. So from there, I have my ratios that I'm going to try and find. So I'm going to do my 3 over 1 equals x over 2. Do my cross multiplication. So I would have x equals 6. That's awesome. Easy peasy. Don't have to worry about any of my Pythagorean theorems or any rationalizing. So I have x equals 6. From there, I'm going to try and solve for y. So I have y over square root 3 equals 3 over 1. Do my cross multiplying, and I get y is 3 square root 3. Question F. Draw my orientation. This is 30, so this must be 60. Across from 30 is 1. Across from 60 is square root 3. Hypotenuse is 2. Set up my ratios. X over square root 3 equals 34 over 2. I would have 2x equals 34 square root 3 divide both sides by 2. And x is going to come out to be 17 square root 3. Looking at the next problem, if I'm going to try and solve for y, I have my ratio triangles. I'm going to set this up with y over 1 equals 34 over 2. That's awesome. That just becomes a big division problem. So y is going to be 17. Last two problems of this type, and then it gets a little bit trickier, but hopefully maybe you guys are even working ahead of me at this point because you're kind of starting to see the pattern, getting refreshed of that 30, 60, 90 stuff that we've done already before. Set my ratios up. I've got x over 2 equals 25 square root 3 over square root 3. X is going to come out to be 50. And I would have y over 1 equals 25 square root 3 over square root 3. And y is coming out as 25. Last but not least in this type of question, draw my ratio triangle out. Set up my questions. I've got x over 2 equals 9 over 1. Cross multiply. X comes out as 18. Set up y. I have y over square root 3 equals 9 over 1. Y is 9 square root 3. We did actually stuff like this first semester, so I'm hoping that that is a good recall for you. And the last part of this, last 3 questions, we have these a little bit more complicated double questions. So what you kind of need to look at is that these are 2 separate triangles that end up having a reflexive side. But we need to, with our eyes, break this down into seeing this as 2 triangles. And the triangle that you're going to start working with is the triangle that you have some information on. And what I mean by that is if you looked at the blue triangle, I don't know this side, I don't know this side, and I don't know that side. All I know is that it's a 45, 45, 90. That triangle right now is useless to me. But if I do take a look at this yellow triangle, I do know that that side is 17, and I don't know that one, and again, I don't know that reflexive. But at least I have a starting point. So I'm going to work with the yellow. I'm going to draw my reference triangle right next to it with the same orientation. This is 30. Across from 30 is 1. There's your 60-degree angle. Across from 60 is square root 3. Hypotenuse is 2. So I need to find that side x, and I also need to find that reflexive side. That reflexive side will then give me the information I need in order to solve the blue triangle. So I'm going to set this up as 17 over 1 equals x over square root 3. Do my cross multiplication. X comes out as 17 square root 3. Got it. Well, I'm going to work on this reflexive side at this point. So we're going to call that question mark. So I'm going to set that up as question mark over 2 equals 17 over 1. Do my cross multiplication, and that question mark, it's not really one of my answer blanks, but that reflexive side comes out at 34. Well, once I know that reflexive side is 34, that gives me the information that I need in order to start my blue triangle. So my blue triangle orientation, I'm going to draw it right next to us. It's a 45, 45, 90. So I've got 1, 1 square root 2. But now that I know that this side right there is side length of 34, that's going to help me solve for z and y. Well, hopefully you remember in a 45, 45, 90, those sides are the same, so I don't really need to do any work for side z. Side z is the same length as that question mark side. So the only side I need to do some math on is side y. So I would have 34 over 1 equals y over square root 2. Do my cross multiplication, and 34 square root 2 is my y. Next problem, I've got my two triangles. This yellow one has that side 6 square root 3, so that's helpful. That's where I have to start with that one. And if I look at this one, my goal, let's get that reflexive side. That'll help me bounce into the blue triangle. I'm going to draw my ratio triangles down below it and set up to solve for x and that question mark. So I would have x over 1 equals 6 square root 3 over square root 3. The root 3's cancel. X comes out at 6. I would have my question mark over 2 equals 6 square root 3 over square root 3. Cross out the square root 3's, do my cross multiplication. The question mark comes out to be 12. Once I bounce over into the blue triangle again, we see that it is a 45, 45, 90. So my side lengths are the same, so that gives me y is 12. I have my ratio triangle of 1, 1 square root 2. So I can set this up as z over square root 2 equals 12 over 1. Cross multiply, z comes out to be 12 square root 2. And last but not least, we've got our 30, 60, 90 triangle. It has that 24 on it. And we have our 45, 45, 90. And we need to solve for all those letters. So let's write them down. We need to solve for side A, side B, side C, and side D. That side B, that's the reflexive side. We did that in the previous two problems. I'm going to draw my ratio triangles below them. So this is 60. And here's my 45, 45, 90. I know I'm going to need them eventually. I know that B and D are exactly the same length because of the fact that they're 45, 45, 90s. I'm going to start over in the yellow triangle. I have 24 over 2 equals A over 1. Do that division. A comes out to be 12. I'm going to solve for side B. So 24 over 2 equals B over square root 3. Well, 24 over 2 is 12. I'm going to force that to be a fraction 12 over 1 to make my life a little bit easier with this cross multiplication. So I cross multiply, and B comes out to be 12 square root 3. Well, we already decided that B and D are the exact same side length because of the 45, 45, 90. So I know D is also 12 square root 3. And last but not least, then we're going to have to solve for side C. So I have 12 square root 3 over 1 equals C over square root 2. Cross multiply, this would be 12 square root 3 times square root 2 equals C. Well, roots go with roots, regulars go with regulars, so that means I can multiply those square roots together to get 12 square root 6. Square root 6 does not break down, so leave it just like that.